All right, this video is going to go over two examples in which we are trying to find a confidence interval for the population mean, and we know the population standard deviation. So in that case, when we know the population standard deviation, then we know that we can use the z distribution in order to normalize our information. The other piece of information that I want to make sure that we have is that your margin of error calculation for a population mean, if that's what we're trying to find, is you're going to take your z of alpha over 2, and you're going to multiply that by sigma over square root of n. So sigma over square root of n still comes from the central limit theorem. It still comes from the fact that we're using a sampling distribution in order to find this approximation. But we are able to use the z distribution because we know the population standard deviation. So let's say that we know scores on exams and statistics are normally distributed. For some reason, we don't know the population mean, but we know the population standard deviation is 3 points. So a random sample of 26 scores is taken, and that sample mean of those scores is a 68. Let's use this to try to estimate the population mean score. So we know that these scores come from a normal distribution. We're going to center our distribution around that point estimate of 68. And I'm trying to figure out, using that point estimate, what interval around 68 do I think that the mean is inside? And I'm going to use a 90% confidence interval. Well, I need to figure out what those data markers are so that this is 0.9 of the data. If you go into your like StatCrunch or into any type of programming, let's go ahead and find that. And I get it's between negative 1.65 or 45 and positive 1.645. So my z is plus or minus 1.645 to get that between. And again, just to go back over like this notation, that alpha over 2, in this case, alpha would be 0.1. That's the opposite of your confidence level. There is 0.05 in each one of these tails. And so another way you could do this is by going to the left side and saying you want that z-score there. So either one is going to get you that same z-score. All right, so let's figure out what that margin of error would be to get to that part on like our actual number line, right? So this is like, oops. So this is like our standardized number that we're looking for on our normal curve, but then I need to put that in some context here. So I'm going to say, okay, margin of error is then, let's say, just 1.645. So, because I know I'm going to add and subtract it from 68. So I don't need that plus or minus there. So just 1.645 times the standard deviation over the square root of n. And then whatever number this is, and I'm going to use StatCrunch in order to find it, whatever number this is, I'm going to say that the mean is approximately or in a boundary that is x bar, so 68 plus or minus what that margin of error would be. All right, so in StatCrunch, one of the things that you are able to do is under stat and then z stats. It's really important if you know whether you're using a z distribution or what we'll do in another video, which is the t distribution. But the z distribution, we just have that one sample, and I have it with the summary statistics. The sample mean is 68 with a standard deviation of 3 and a sample size of 36. And I want to find a confidence interval for the mean and 0.9 right here. And let's go ahead and have it do the plot for us. And let's show the critical value just so we can see all the things that I don't want it to store it in a data table. Let's just have it compute. All right, so our standard error, now that's not the same thing as the margin of error. That's going to be 3 divided by, yes, the square root of 36. I had to do that math in my head, sorry. 3 divided by the square root of 36. Square root of 36 is 6, and 3 divided by 6 gives us that. So that's what that standard error calculation is. We already know the z-score. The lower limit, that's going to be what I put as my lower bound and then my upper bound. So 67.2 is my lower bound. And my upper bound is 68.8. Now let's talk about what this measures. This says that we are 90% confident that the true mean exams score is between 67.2 and 68.8. Okay, so that's what this interval means. I think that the true mean is somewhere in that interval based on this point estimate with a little bit of some margin of error there. All right, let's look at another example. The specific absorption rate for a cell phone measures the amount of radio frequency energy absorbed by the user's body when they are using the handset. Every cell emits that radio frequency, and different phones have different ones of these measures. For the United States, there can be no more than 1.6 watts per kilogram. Find a 98% confidence interval for the true population mean of these rates, assuming that the population standard deviation is this right here. Now, what I don't have is I don't have an n given to me, and I don't have a sample mean given to me. Like, I'd have to figure that out here in the table. We could do that with methods that we have used before, but I'm actually going to split screen this with StatCrunch, and we're going to put it into a data table. All right, so it's going to take just a second to put this data into variable 1. And then I'm going to do the exact same steps that I did before to calculate my confidence interval. But this time I'm going to say that I have the data instead of with statistics. And then we can see all the menu options that are available when I say that. Okay, so under stat, Z statistics, 1 sample, we're going to say with data. All our data is in variable 1. Standard deviation says optional. Well, I know it, so I'm going to put it in there. I guess otherwise I'd use the sample standard deviation, but then it wouldn't be a Z. So put that in there. No group by confidence level. It wants a 98%. Yes, show the critical value. And let's not worry about any of those. I guess we could do a box plot. That would be fine. Okay, compute. Okay, options 1 of 2. Well, where do we go into? I don't know how we find the other one. Maybe if I zoom out? No. Okay, whatever. Okay, so it found for me the sample mean and n. So n is, if I go back over here, n is 30 with a sample mean of 1.02. And then if I take a look at the z-score, it tells me that that z-score, again, for 98% being in the middle, okay, so it tells us this, is plus or minus 2.326 is what we'll have there. Now, the margin of error calculation would be that z-score times the standard deviation over the square root of n, where this number is 0.0615. If I take this sample mean and I add and subtract that margin of error calculation that I get here, the result is the interval 0.881 to 1.167. So then we can say that we are 98% confident that the true mean, SAR, is that what it was called? Yes, SAR, for cell phones is between 0.881 and 1.167, and what were the units? Watts per kilogram.